Good morning, guys. Mr. Middleton here. Today we're going to talk about simplifying radicals with fractions. By the end of this lesson, you should be able to simplify any radical expression that has a fraction with it. Well, most radical expressions that have a fraction in it. We'll talk about other examples that will trip us up a little bit more tomorrow. Okay? Alright, our fraction rules are going to be pretty similar to our multiplication rules. If you forgot our multiplication rules, they're pretty simple. With radicals, we think like this. Insides can divide insides, outsides can divide outsides. Okay? And then we'll look at a couple different ways to write our fractions. So let's just jump into our example. Alright, number one, we have radical 11 over 49. So it's a fraction inside the radical. Okay, that means it's not simplify. We need to try to simplify it. Alright, so first we look to see, can we divide or simplify this fraction, 11 and 49? And we can. But we can rewrite this. I just want you to know that if I write it as radical 11 over 49, that's the same as writing it as radical 11 over radical 49. Okay. And that helps us in this case because, well, 49, if you remember from your list of perfect squares, is a perfect square. Okay? 49 breaks down into 7 and 7. And so in our denominator now we have 7. No radical. Got it out of the radical. In our numerator, radical 11. We can't do anything with that. That's just 11 and 1. So here's our answer to our first fraction. Okay. So again, to recap, we split these, radical 11 over radical 49. We simplified them separately. If we were able to, we'd simplify them again. But we're not, because 7 is outside the radical, 11 is inside the radical. Alright, so number 2, we'll look at the same thing. Now we have radical 25 over over b to the 4th. No simplifying these together. So I'm going to separate them. I have radical 25 over radical b to the 4th. Radical 25, that's 5 times 5. Radical 25 is 5. B to the 4th, radical b to the 4th is b squared. 2 pairs of b's there. Okay, and so here's my answer. Okay, got those answers for those two. Alright, now looking at number 3, we have radical 25p to the 3rd over q squared. Again, looking to see if I can simplify any kind of way, and I can't, so I'm going to separate it into radical 25p to the 3rd over radical q squared. Then I'm going to simplify. So as I do that, 25, that goes to 5. P to the 3rd, I have a pair of p's, and I have one p that doesn't have a pair, so it stays inside the radical. Okay, and q squared, radical q squared is just going to be q. Alright, and so I look to make sure there's nothing I can do to simplify it, and there's not. Here's my final answer. Number 4, we have radical 75 over radical 16t squared. Okay, can I simplify this? No, I can't simplify. There's nothing goes into 75 and 16. So I'm going to separate. I have radical 75 over radical 16t squared. And this is really nice. This is really nice when we have a perfect square in the denominator. Okay, square root of 16 is 4. Square root of t squared is t. So I get rid of the radical in the denominator. We'll find out tomorrow that can present a challenge to our problem. Didn't in this case. Alright, with 75, I'm going to break it down this way because I have space there. I can multiply 25 times 3. 3 is prime. 5 times 5. Pair of 5s. Okay, so I have a pair of 5s on the outside. I have 3 with no pair left inside. And then I check to see, can I simplify this? 5 and 4 don't simplify anymore. There's nothing else inside the radical to simplify with 3, so this is my final answer. Okay? Alright, number 5. Again, we're always looking to see, can we simplify first? And in this case, we can. Okay? So we have radical 88 over 11, but 88 divided by 11, they're both underneath the radical. You can simplify that or rewrite it as radical 8. Okay? And so that's radical 8. We can simplify radical 8. Radical 8 goes 4 times 2, 2 and 2. And so we have a pair of 2's that go on the outside. And we have a 2 without a pair. It stays by itself. So 2 radical 2. For number 6, again, we're looking to see if we can simplify. 12 and 27, what goes into both of those? 3. So I'm going to factor out that 3. Write my thing out. I have 4, 9, okay. And then a cubed and a, that cancels out, leaves me with a squared. Okay. So now I have, and I kind of misspaced my sheet, but now I have radical 4a squared over radical 9. Well, radical 9 is 3. Okay, pairs of 3's. Radical 4 is 2. A squared is a. And so here's my answer for number 6. 2a over 3. No radicals left. Okay. Number 7. I have radical 90 over 5. Okay, I can simplify that fraction. It gives me 1 radical 18. Okay. And now I'm just simplifying radical 18 like we did before. 9 and 2. 3 and 3. I have a pair of 3's that goes to the outside. I'm writing this where I have space. I have a 2 without a pair. Stays inside. My answer. And number 8, I do the same thing. Okay, 27 and 3. That simplifies to give me 9. X cubed divided by x simplifies to give me x squared. I break this down. X times x. I have a pair of 3's, a pair of x's. So on the outside I have a 3, I have x, there's nothing left for the inside, so here's my answer. Alright, so that's simplifying radicals. Here we learned that we can separate a radical. Okay, if we had a fraction under a radical, we can separate it and make a radical divided by a radical. Simplify that way. We also learned that we can simplify inside the radical, and we should always be looking to simplify when we take our square roots. Okay. Tomorrow we'll look at what happens if we do end up with the radical in the denominator, and that will finish up our simplifying radicals expressions in this kind of way. All right. See ya.